All right, hello and welcome. Just give me a few moments here to make sure the audio is working. I'm going to try the next question here. This is going to be as far from land as possible. Audio is working. I'm going to try as far from land as possible. LeetCode number 1162. Let's get that going. Again, try to do these as quickly as I can. Or just quickly. We'll just try to do them quickly. Given an n by n grid containing only values 0 and 1, where 0 represents water and 1 represents land, find a water cell such that its distance to the nearest cell is maximized, and return the distance if no land or water exists in the grid, return -1. Distance used in this problem is the Manhattan distance, the distance between two cells, x0, y0, and x1, y1, where x sub 0 minus x sub 1 plus y sub 0 minus y sub 1. Manhattan distance. Yeah, the reason they call it Manhattan distance, I think, is because the Manhattan is a grid. The Manhattan distance. N by n, 0 water, 1 land, water cell, land or water exists in the grid, returning. Oh, its distance to the nearest land cell is maximized and return the distance. Oh, interesting. Okay. Oh, okay. That's interesting. Okay, I think what I do is I find the border of the land, and I do a level or a traversal across the water, and I take the however many levels it takes to get to complete the iteration, and just keep looping until I've reached all of the water, gone through all of the water. And yeah, all the water that borders the land is what I should start with. Start iterating there, and then that level or traversal, when it completes, that'll give me what I'm looking for. That's pretty straightforward. That's a pretty straightforward solution. That should be linear time, and yeah, not too bad. Okay, that should be fine. Let's go with that. Okay, so let's do first things first. Constant row or number of rows is grid.size. Number of columns. Let's do for int row, less than m, column. I'm looking for each direction as well. We'll do the directions in a different way. Actually, we'll do it like a more mathematical way. Inbounds checks as well. So we'll do if. So we'll do vector of pairs. I actually want a queue of pairs. Queue is a little better than vectors for this. Positions. So we'll just say level. It's fine. And we'll say land present equals true. False. Just say land present or equals grid of RC. Let's do if grid of RC is 1, which we said 1 represents land, right? Then we're going to say land present equals false or equals true. And we're going to say for each direction, so int I is 0, I is less than 4. Say dr is 0, dc is 1. I'm going to say swap, so increment I, swap dr dc, and multiply dc by -1. Okay. I'm going to say const int new row, so row plus dr, new c is column plus dc. If new row is greater than or equal to 0, and new row is less than m, and new column is greater than or equal to 0, and new column is less than n, then it's inbounds, and we can say and grid of RC is 0 or not to negate this. Then this is water near the land. We could say level dot push in place, more like don't know, can I in place? I don't know if it actually matters if I do it that way or not. Push an RNC and not visited VD of RC. Could do single key values, but I don't want to do that. Makes things more complicated than it needs to be, I think. Visited of m by n, it's going to be all false. For each row. VD of row, VD of column, this column. Right, make sure that's initialized. If not grid and not VD, then I'm going to set VD of RC to true and push this into the level. Okay. And the count is going to be int. Count is initially 0. We're going to do a bunch of while loops here. Oh, quite a few of them. And return if count really should be 1 initially, I think. Yeah, the thing that's important here is actually we'll start off at 0. Yeah, if this is empty, it'll just what's the distance? Hold on. This should be 1, 2, right? Yeah. So the initial one should be 1, and I'm going to increment the count afterwards. Initially 0. Let's say we process all those. We don't have any more water. Count is 1. We return 1. Okay. That's fine. So we'll just say if count is 0, then we return -1. That means that this was empty to begin with. Okay, that's fine. So we have the level as a queue. Now we can say while not level.empty. We have this thing here. Next level. Next level. Same thing. While it's not empty. We're going to say const auto p is level.front. Actually, I want to destructure this, I think. Int and then pop. And then we're going to say for each these positions. So for so if not land present, also if not land present, turn -1. By the way, so there's no land, then return -1. If there's no water, return -1 again. Here we're going to say we go in each direction. And we say if it's inbounds and it's water, right, not grid, and it hasn't been visited, then we mark it as visited and we push this into the next level. And then finally we just copy the level, next level into level. Okay, yeah, that should do it. Let's see how much time did that take me. It took me almost 10 minutes. That's wrong. 1, 2. Count is 0. What level is not empty? Level that push. What? Oh, this is wrong. The other one's wrong too. Should be NR and NC. Okay. All right. That was my mistake. Something of a typo. Something of a typo there. Okay. And I think I'm gonna go for it. Just gonna go for it. Why not? Why not? Don't want to test anything. Don't want to test it. Hey, you got there. Sweet. All right. That was pretty quick too. Around a little over 10 minutes. So we'll go 4 more times. And then if you like the video, give it a like, subscribe for more. And also I'm gonna go ahead and 1, 2, 3, 4, 5, 6, 7. I'm gonna go ahead, submit this a few times, and then I'm gonna restart the stream on another question. I think I want to 1, 2, 3, 4, 5, 6. I think I want to maybe take a break after this one. Going kind of quick here. 1, 2, 3, 4, 5. I kind of explained. Hopefully it's clear what I did to solve this. Hopefully it wasn't too complicated. All right. Thank you for watching. Take care.